Hello, this is exercise 14b for Year 12 mathematicians, and we're looking at stationary points and how to find where they are, and also determine the nature of the graphs, and that will become more obvious later on. But stationary points, as a matter of interest, are these red dots as far as we're concerned. The red dots are wherever you notice it. Basically, there's a top and a bottom to these. By that I mean it doesn't go any higher than that in that particular area. So this would be called a maximum point, I suppose, and this would be called a minimum point. Now, it's not a minimum point in as much that the graph then goes up again, and potentially, you know, you can see that there is higher than this supposed maximum point, and over here this is lower than this supposed minimum point. But locally, that's the posh word, locally we say that's a maximum and minimum point. So a few questions just to remind us what differentiation is, and also this thing called d2y by dx squared. Listen to how I said that, d2y by dx squared. It's basically where you differentiate once and you differentiate again. So I'll do the first one for you, I'll leave you to do the others. Remember, to find dy by dx, you bring the power down to the front and multiply, and then drop it down the power. So this is 3x squared, and this one becomes minus 10x. Hopefully you can do that. But then, you, having done it once, you do it again, and 2 comes down to the front, gives me 6x, and this just becomes minus 10. So see if you can do all the others and get answers from me for those, please. Okay then, so I'm hoping you paused the video. I hope you've done these 3 questions. There's a couple of things here which I noticed might cause you a few problems, so I'll go through them. So this first one, the 4 comes to the front, gives me 8x cubed, and you should know that the 8 disappears. Differentiate again, I get 24x squared. I think that was the easiest of the 4. This one, I just got to be a bit careful. This means x to the minus 1. So I'll use that when I come to differentiate it. The 2 comes to the front, gives me 6x. Minus x to the minus 2. Easy to go wrong with those negative powers. And then if I differentiate again, I get 6. And here minus 2 comes under the front, that's plus 2x, this time to the minus 3. Now we might want to write that in some other way. For instance, you could write it as 6 plus 2 over x cubed, amongst other ways as well. But certainly we want to be able to get this answer. And this last one, you should have got x differentiated becomes 1, and this again as a dodgy power, x to the half. So when I differentiate, it becomes minus a half x to the minus a half. I will then want to differentiate again. Again, a number will disappear, so that 1 will disappear. Half times a half is a quarter, minus times a minus is a plus. So I think this is a quarter x to the minus 1.5, or better written as minus 3 over 2. Okay, and again, if you wanted to know what this was as a fraction, if you prefer, the 4 goes on the bottom, it's already on the bottom. The x, because the negative power goes on the bottom. It's cubed because there's a 3, but then it's a square root of it, because it's a 2 on the bottom. So anyway, next slide is really just to tell you what stationary points are and how to find them. A stationary point or turning point of a curve are the points where the gradient is 0. This is important. We're going to use this fact lots and lots and lots to find where these stationary points are. So on this graph here, for instance, you'll just notice that this point here we describe as being a local maximum, and notice I've written here dy by dx is 0. So by that I mean the gradient is 0, so effectively it goes straight across at that point. And on here it does a similar trick where the gradient is 0, it's flat. So there it is also flat, and therefore we call that a local minimum. Effectively no one ever calls them local, we know what we mean by it, we just probably call it just a maximum and a minimum. So on this equation, this expression here, but y equals x cubed minus 3x squared minus 9x, it says find the coordinates of the stationary points. My first job is always to find dy by dx. When you find dy by dx, you can then do something with it. So this is 3x squared minus 6x minus 9. Hopefully you're okay with that. Now it says find the coordinates of these stationary points. So I know I'll find stationary points when it is equal to 0. And so you should write equal to 0. And then we need to solve this equation. So you can just quite simply put that into your calculator. There's other ways to do it as well. If I've got my calculator here, yes I have. So you might as well go into menu A. So you want a polynomial equation, it's degree 2, and just type them in. 3, -6, and -9. Now, you could have done it by factorization. My answers have said that my first answer is x equals 3, and I've got a second answer, x equals -1. Now, these, of course, are just the x coordinates, so I now need to know what y is, and this, I'll need to use this equation to know what it is. So I sub those numbers in, I get 3 cubed minus 3 lots of 3 squared, and minus 9 times 3, so let's just do that now. Menu 1, 3 to the power 3, and again it's quite easy to do this in your head, but I'm just doing it probably the way that you'll most likely do it. So I've typed all that in, I get minus 27. And if you do the other one, that's a minus 27, honest. And if you do the other one, when x is -1, well, I get -1, cubed is -1. That gives me -3 plus 9. So I reckon, if you type that into your calculator, I reckon you'll get 5. Now, one thing that this has done is really just show me the coordinates. I've got at 3, -27. Again, I wrote that bad there. It's a 3, -27. And at -1, 5, I've got stationary points. They are definitely my stationary points. I can write those stationary points. The one thing I don't know is what type of stationary points they are. But I suppose it doesn't ask me to. It just says find the coordinates. So fair enough. That's what we wanted. Stationary points at 3, yeah, that perfectly. Okay, here's an exercise then, which is broadly the same as before. What is slightly different in as much this one, you're going to find on both of these examples, you're going to find dy by dx first. So that's what I want you to do. I want you to find dy by dx for both of them. And when you've got that, I want you to set them equal to 0. And we always set it equal to 0 because it says find the coordinates of the stationary points. And one thing we know is that dy by dx will be 0 at these points. That's the trick that we use. When you do this, you'll find there's only one answer, x equals something, whereas this one, when you do it and you put it in your calculator, you'll get 2 answers. Get me a y equals for all of them, and then you'll eventually be able to say what the stationary points are. The stationary points, on this one I think there's only one of them, whereas on this one I'm hoping you're going to get 2. So pause the video, and I'll put the answers, well, my answers, up in a bit. Okay, that's me. Again, I'm hoping you've done it already, so I'm going to quickly do it now. 2x minus 4 here. If I move it over, I get 2x equals 4, which therefore is x is 2. Substitute it in. I get 4 minus 8 minus 4. I think it's 1. So again, 2, 1. This one here, I get 6x squared plus 6x minus 12 when I do it. And again, you might as well just menu. Probably the way you did it, as I say. So I get 6, 6, and 12, and it gives me 2 answers. Well, first answer is, it's minus 12. It helps if I type it in right, because I didn't. Negative 12. Okay, I've got some horrible answers then. 1 and minus 2. That sounds a lot better. And when I substitute 1 in, I get 2 plus 3, 5, 6. I think I get minus 6. And when I put minus 2 in, I just put it into my calculator, I get 21. So therefore 1, minus 6 and minus 2, 21. And they actually work. Excellent. So we do need to be able to determine the nature of the stationary points. We need to know whether it's a maximum or minimum. We do this using the second derivative. Well, I talked to you about that at the start, d2y by dx squared. So this is what d2y by dx squared is. This is how we say it. A maximum point comes about if we basically, look, we find d2y by dx squared. We know what our stationary point is. It's got an x coordinate. And whatever x coordinate is, we sub it into this thing. And if d2y by dx squared is less than 0, then we know it's a maximum point. If d2y by dx squared is greater than 0, then we know it's a minimum point. There's obviously a question that comes about of what happens if it's equal to 0, and the answer is we can't be too sure of what it is. So if you ever do get d2y by dx squared, we'll talk about what that tells us a bit later. That it certainly isn't a maximum, it certainly isn't a minimum, straight off. It could be a minimum. I could think one, for instance, that is a minimum point. But there's also these things called points of inflection, and we'll look at those later. So here's an example. It says we've got this point, this curve, y equals this. Decide whether it's a maximum or minimum. So we do the same thing. We do dy by dx, 2x minus 4. We set it equal to 0. That will tell me where it is. So 2x, this sounds like the question we did before, x equals 2. Having got x equals 2, I need to know what it is in terms of y, so my y value would be 2 squared is 4 minus 8. This is the one we saw before. This is minus, that's minus 4 minus 3. So good. So now I've got this. I now have to find d2y by dx squared. d2y by dx squared, then, let me just point out, having differentiated it once to get this, I differentiate it again. And differentiating 2x minus 4 just gives me 2. Now, 2 is positive. This is greater than 0. I don't have to do much work here. Because it's greater than 0, weirdly, this is a minimum point. I always think they're the wrong way around. You'd think a minimum point would be less than 0. You think a maximum point would be greater than 0. But no, they're the other way around. This is a minimum point at, what was my coordinate? 2, minus 3. Minimum point at 2, minus 3. It worked. Here's another question. So I've got much more complicated. Do the same thing. dy by dx equals, differentiate this, gives me 3x squared plus 6x minus 9. This looks like the other one I did before. I'm not sure if it is, but I set it equal to 0. Now I'm going to divide it all by 3, because then it should be the case I can factorize it. It's x minus x plus 3, x minus 1. And therefore I've got solutions at x equals minus 3. X equals minus 3 and x equals plus 1. If you remember, what we then do is we find d2y by dx squared. d2y by dx squared on this, without the simplifications, give me 6x plus 6. And this is where it particularly comes into its own. This is where I have to substitute these values in. So to do that, I write when x equals minus 3, and I write d2y by dx squared equals, and I put minus 3 in, and you can see I get minus 18 plus 6, which is minus 12, which is less than 0. And when it's less than 0, it's a maximum. But when x is 1, my d2y by dx squared, well, what do I get now? Put 1 in, I get 6 plus 6, which is 12, which is greater than 0, so that's a minimum. Now, have I drawn this picture? I'm hoping I have. Yeah, I kind of have drawn this picture. So I've got a maximum at minus 3 equals 37. I don't think I substituted those. Clearly I could have done. But I've got a maximum at, can't even see what I'd wrote before, a maximum at minus 3 and a minimum at 1. And you can see on my graph, I have got a maximum. And I have got a minimum in the places I said there would be. Now, look, there's a couple of questions for you to do. So I want you to have a go at these, and then I'll ping up my answers, and then hopefully you've got the same answers as me. But if you're struggling with this, I want you to have a look at it, and perhaps bring it to me during class. Here, I'll pause it there. Yeah, I'm hoping you've done that. Let's do the first one, and I haven't got much time, but first job, you find dy by dx. That equals 3x squared plus 6x. You set it equal to 0. That gives me, I can factorize this, or you can get the same answers as me from using the calculator. That gives me answers at x equals 0 and x equals minus 2. Now, you obviously then need to define d2y by dx squared, and if you do that, you get 6x plus 6. And if I put 0 in there, so x equals 0, I get d2y by dx squared is 6. So that is greater than 0, and therefore it's a minimum. And when x equals minus 2, d2y by dx squared, chuck it into that, I think is minus 6, which is less than 0, and therefore a maximum. Like I did say, I promised the pictures. There's my pictures for both examples. Hopefully you've got the same as both of mine. Just looking at this, well, I've got 0, minus 2, that works, and minus 2, 2. I didn't find the y points. But in class, we'll do that last example, and we'll do exercise 14b, and it should be okay. Thank you very much.